So hi everyone, we are back with another video. So in this video, we'll be taking a live interview, and you guys will experience what it feels like giving an interview for a top product-based company like Amazon, Facebook, Google, or Microsoft. So today we have two Varuns with us. One is me and one is the other. So let's see how Varun calling Varun goes. So before we start, let me give a brief introduction about myself. I am Varun. I graduated from NSIT a couple of years back, and I worked in Expedia and Microsoft. And most recently, I completed my master's from University of Wisconsin at Madison. So Varun, like the other one, do you want
Yeah,
to give a brief introduction about yourself?
yeah, sure, why not? So just comparing with you, I am from his rival college, this Varun's other rival college, Delhi Technological University, and
Yeah.
I graduated in 2018. Like, I don't have a stacked up CV, like he has like no MS, no anything. And I've been working with Amazon for the past 2 years, and currently I'm working with the automated advertising teams. So those notifications and emails that you get that you did not buy this product, you've left in this cart. So if you want to blame someone, my team is to blame for that. So we are worldwide managing those kind of emails and push notifications that go out of the system.
Okay, cool. So Varun, I'll be asking you a coding question in this. So
Okay.
guys, stick till the end of the video to find if Varun is able to solve the coding problem or not. So, hi Varun. So let's begin
Hi,
with the
Varun.
coding problem that we have for you.
Okay.
So, let's say that I give you an array of numbers. It's all positive
Okay.
integers, and
Okay.
uh, so let me just space the problem for you. Okay. So
Okay.
let's say that you have this array 5, 2, 4, 5, 1. Nothing
Okay.
fancy about it. But what these numbers represent are the heights of the towers that I'm talking about. Okay.
Okay.
For example, 5 means that I'm talking about a tower of height 5. 2 means I'm talking about a tower of height 2. 4 means I'm talking
Okay.
about a tower of height 4. So
Okay.
now what I want to know is if I threw water from top of these towers, how much
hmm
water will be trapped inside these towers?
Okay.
You can assume that the width of each of the towers is say 1 meter or centimeter. I'm not interested in the unit, but it's 1 unit.
Okay. So
Let's
all of the buildings will have the same width. I
yeah
can assume that.
let's assume for this problem all
Okay.
the buildings have the same width. So let me
Okay.
walk you through a brief example, and then you can ask me some questions if you have any. Okay.
Okay.
So let's say that in this scenario, if you are at the
hmm
second building and at the third building, you can see that I can trap this much water which has been colored in blue. Okay,
Okay.
so there will no water be trapped in the last one because there
hmm
is nothing to hold the water, right?
Yeah. Okay.
So what I'll give you is I'll give you an array of integers, and I want you to write a
Sure.
function that accepts those arrays of integers and returns a single value that is the area of water that can be trapped between these towers.
Okay. 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 So, can there be any buildings can there be a place where there is no building? Like, can there be a building of zero height?
Yeah, they can be a building of zero height.
Okay. And okay. And just one more clarification. I am assuming that these will be non-negative numbers, right?
Yeah. They are heights, so let's
Okay.
not think about them being negative.
Okay. Sure. Okay. So, I think I can notice a couple of things here. Obviously, if there is, you will, if there is only one building,
Yeah.
you can't hold any water. And same goes for, I think, two buildings also, because two buildings will also not be able to hold any water. So this problem, I think, only begins when there are at least three buildings. Only then the water can be trapped.
Okay.
Okay. And okay. Okay, all right. So, okay, now I'm just thinking on what factors is the water being trapped on top of one building depending upon.
Okay.
So, okay. So is it okay if I like draw something on my paper here?
Yeah, sure. Feel
Just,
free. Feel free to think about it. Just try to talk loud while you're whatever
yeah,
you're thinking.
okay. So it is given 5, 2, 4, 5, 1. So okay. So okay. Okay. So I think a building will only be able to trap water if it is smaller than its adjacent, if its height is lower than its adjacent building.
Okay.
Like for example, you had given an example 52451, right?
Yeah.
So if I make it like this, 526, 5 and 1,
Yeah.
right?
Yeah.
So in your case, the building 4 is able to trap some water, but in my case, since 6 will be like going well above and beyond, there won't be
Okay.
any water trapped on it.
Yeah.
So I think we need higher buildings on the sides for for one particular building to hold some water.
Okay.
Okay. So I think if I compare uh, the height of one building with its neighbors, is it? I'm trying to see like if there is a relation between the neighbors' heights and the building's own height.
Okay.
Okay. So okay, like it looks like okay. So in this case, so like for example, for the second building,
Yeah.
the left neighbor is of height 5, right neighbor is of height 4. So we are, I think we are, if we just take the maximum of those, then, okay. No, but maximum won't work. So I think yeah, no, maximum won't work because like if you remove the second last building,
Yeah.
in that case the water will not be basically 3 units. The water will come down. So I think maximum is not the right answer.
Okay. Nice observation. Keep going.
But then again, so I can't take the maximum. Okay. So okay, yeah, okay. So okay, let's see. Okay, if I make this 6, 2, 4, 6, 1, 2, 4, 5, 1, 7. Okay. Okay, so I think that I'm seeing a pattern here.
Okay.
Like the water is not like directly depending on its on just its neighbors. It's actually depending on like what is the highest bar on my either side. So for example, if I take an example which I have written 624517.
Yeah.
So in that case, for the building with size 2,
Yeah.
there will be 4 units of water saved basically,
Okay.
which will okay. Am I thinking right? Yeah. So basically, if in case there was a 8 in the beginning,
Yeah.
now water will become 5 units, which is not depending on now building of height 6, because now we have even further higher buildings on either
Okay.
side, which are basically 7 and 8.
Okay.
Okay. Okay. So I think okay. Yeah. So I think if basically yeah. Okay. So let's say we had two buildings of height 7 and 8.
Yeah.
So obviously you can't water can't stay up to the level of 8 because it will flow out from the 7th side.
Yeah.
So I think if I can find what is the highest bar on my left and highest bar on my right,
Yeah.
and take the minimum of that basically, and then the difference between my height and those two, the minimum of those two,
Yeah.
that will be basically the amount of water that is on this particular building's top. And if I repeat this for all the buildings, I think I should be able to get the answer. Let me just dry run this once.
Yeah.
So for 5, so obviously for 5, it is the first building, it can't hold water. Then for 2, it will be minimum of 5 and 5 minus 3, which is which will be 3. Then for 4, it will be minimum of 1. Okay, so it will be 0. Okay. Okay, yeah, I think this approach will work. Like I need to find out what are the two highest bars, one on my left, one on my right, and then I'll take the minimum of those two
Yeah.
and subtract my own height from it, and
Okay.
that will be the amount of water which is on current building stop, and then I'll repeat this for all the buildings.
Okay. Okay. Yeah. Uh, it seems like a reasonable solution. So how do you plan to find the maximums on either sides?
So I think the basically, if I'm just thinking out loud, the simplest or the naive solution would be just to traverse the array,
Okay.
and for each point find out what is the maximum on my left, and then find out what is the maximum on my right. Take
Okay.
the minimum of those two, subtract it, then proceed to the next element and repeat the same process.
Okay. So in this way, what would be your time complexity?
Okay, so time complexity, since for each element I am finding out the minimum and maximum. So finding out minimum and maximum will take one traversal of the array, which will be linear time.
Okay.
And since I am doing this for each and every element in the array,
Yeah.
it will come out to be n square, order of big O of n square time complexity.
Okay. And what about the space?
I think there won't be any extra space needed because I am not. No, since I'm not creating any additional arrays or anything like that, so the space complexity will be constant.
Okay. Nice. Um, okay. So
So, so can you
can
give
you,
me some hint? Like, is this the correct solution?
yeah, so
Like, is
you
this the
are
correct approach?
you are on the absolutely right track, but I would like to know if there is a faster way to solve this. Can you think of
Okay.
like something that's faster than n square to solve this problem?
Uh, so I mean, so
Take your
one
time.
traversal is
Yeah. Yeah.
yeah. I mean, one traversal is definitely needed because we need to visit each building.
Yeah.
And so the okay. Okay, see, one traversal will obviously be needed, but like, I mean, I need to visit each and every building at least once. But
Yeah.
the time that is getting wasted, which I can think of, is in basically finding out the minimums and the maximums. So we can improve upon that, but it will cost us some extra space. So what I can do is, like instead of finding the maximums and minimums each
Yeah.
time I am visiting a building, I can pre-process that. I can create two separate arrays, one for holding the maximum from the left side, other from holding maximums from the right side. I'll create two separate arrays by
Okay.
pre-processing.
Okay.
And then as I am visiting the array, I will basically directly have what is the maximum on my left and maximum on my right. So in that case, our time complexity will come down to linear
Okay. Okay.
because we have the maximums readily available, but
Okay.
it will then cost us some extra space, which will also be linear because we'll be creating two arrays, so order of n plus order of n, which will remain order of n.
Can you walk me through like how will you find that in linear space? Can you walk me through an example like the one we have?
Okay, so I'll call it as left max, okay, and I'll call it as right max.
Okay.
So left max will be 5, then maximum of 5 comma 2, which will be 5 again, 5 comma 4, which will be 5 again, and then 5 comma 5, 5 again. So everything is 5 basically because the largest element is on the leftmost position. Then
Okay.
let's talk about right. Right max will start from the right end.
Okay.
So it will be 1, then maximum of 5 comma 1, which will be 5, then 5 comma 5, and then 2 comma 5, which will again be 5,
Yeah.
then 5 comma 5, which will again be 5.
Okay.
Okay, and let's write this as 5 2 4 5 1.
Okay.
Okay, yeah, so now you have this. Okay, now you start visiting this array.
Okay.
So when you come to 5 basically, so let's take, I'm just writing simple pseudocode only.
Yeah.
So let's say I goes from 0 to 4. Then
Okay.
what you do at basically when you are at 5, building
Yeah.
with height 5,
Yeah.
you take minimum of basically left max of I, comma right max of I, and then you subtract array of I. Okay,
Okay.
so
Okay.
let's call it as water. and here we initialize water as 0.
Okay.
Okay. So yeah, so here you can see basically we are traversing these buildings and we have
Okay.
left max and right max readily available. So
Okay.
it will be just constant time operation there. In
Okay.
the end, we will return this water.
Okay. Cool. Yeah, I think this should work, but like I had one more question. Like, can you tell me how you filled the left max or right max array? Can you tell me like how you got the values for
Okay.
those? Just
Okay. So, okay, let me do one thing. Let's initialize left max new array of 5.
okay.
Similarly, right max of 5. Then for I equals 0 to 4 basically. I'm just
Yeah,
writing the
yeah. Let's
pseudocode
not
here.
worry about. Yeah, yeah, yeah.
Okay. So left max of I will be a maximum of left max of I comma array of okay. I think no, this should be the previous one, and this will start with 0. Okay. So here I will write. So first element I will basically initialize with the uh, firstmost value in the array,
Okay. Okay.
and similarly for right max of basically this will have to be 4, will be array of 4.
Okay.
Okay.
Yeah.
And
Don't worry about right max.
we
I get the gist. I get it.
okay, so basically we'll just do from the reverse.
Yeah. So basically, you are pre-processing and taking like some order and time to make your life
Hmm.
easier. Okay.
Yeah,
Nice. Nice. So this
but
takes order and time and order and space, right?
yes,
So
correct.
um, great. Like we have been able to come very close to a like very optimal solution. But
Okay.
what if I tell you that there is a way that you can
Hmm.
even get rid of the auxiliary array space that you are creating?
Okay.
Like,
So you're saying we can do this in linear time and constant space.
yes.
Okay. Okay. Let me think it over.
Yeah.
Uh, think- so it's- so basically that much is for certain that I definitely need the left max and the right max for me to calculate the water. But how do I get that without pre-processing? Yes, can do it, but interesting. Okay. I think okay.
Like what thoughts are coming in your mind?
So I think we can. There is some mathematical property that we can use. See, at on this line,
Yeah.
like so, I'm seeing that these are two maximum values. Then
Yeah.
I'm taking the minimum of those two.
Okay.
So I think something can be done here because see, okay. So like I mean, this minimum will always give me. Okay. 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 Got it. Okay. Okay, so what I see from left max and right max that I've pre-calculated above below the example that left max will obviously be always non-decreasing. Its values will never go down. So
Okay.
like if it was 5, it will at least remain at least 5 even towards the end. It will only go up.
Okay.
And right max on the other hand will be a strictly strictly non-increasing function.
Yeah.
So basically left max will go something like this and right max will be something like this.
Okay.
And then I'm taking the minimum of those two. So okay, so okay, I think I got it. I mean, okay, so okay, let's say at any point I have, okay, let's say we forget about this pre-processing. Okay, now we have two pointers. One I place at the starting of the array and one I place at the ending of the array.
Okay.
Okay, now, and let's say I have only two variables now. Okay, so not, I have only two variables which I initialize with the first value in the array, which was 5,
Okay.
and I have right max, which I initialize with the last value.
Okay.
Okay, so now, yeah, okay. So now let's talk about the element, and I have, uh, let's say there is one pointer start, which is at 0. There is one pointer end, which is at 4, basically the last index. Okay. So now
Okay.
for end is equal to fourth index, if you see, which is
Yeah.
1, right? So if I have to find out this function like minimum of left max comma right max, right?
Yeah.
This is what I have to calculate. Minimum of left max comma right max. Okay. So now since right max is already 1, right? So and after this right max will only increase. It will never go down,
Okay.
and left max is already 5. So by the time it reaches the last element, its value will at least be 5. So the
Yeah.
minimum is always going to be the lower value, which basically means that minimum of this function for the last building will
Yeah.
always be 1.
Okay.
That much I am guaranteed. Okay, and what I'll do after this, okay, after this I decrement the basically my last pointer. Now my end will become, start was at 0, end will become now 3, and I
Okay.
update my right max basically by taking the maximum of right max comma that value. So now my left max becomes 5
Okay.
and my right max becomes 5. Okay, I think I got the approach. So
Okay.
basically you just put two pointers.
Okay.
Okay, we are not doing any pre-processing, and I just see which one is higher. Is my left max higher or is my right max higher? So
Okay.
whichever one is lower, for that particular element, I can find out the value of this function, minimum of left max comma right max, without having to look through the entire array. But I can't do that for the higher value. I can't do that, but for the lower one I can. So at any point of time, whichever
Yeah.
one is lower,
Yeah.
I calculate for that, move that pointer further.
Okay.
Then let's say in the next iteration, my right side is lower. Then I
Okay.
calculate for that and bring it closer. So at
Okay.
some point, these two will meet, and then at that point, I stop my iteration.
Okay. So
So
like
basically, yeah,
we were able
yeah.
to
I mean,
guarantee that because of that increasing decreasing property, right? That this will.
yeah, because yes, because left will always keep increasing or stay constant, and
Okay.
right will always keep decreasing or stay constant.
Yeah.
So whichever one is lower, by
Yeah.
using that, I can find out the value of this function.
Okay. Yeah. And what will be the time complexity in this case? Order n, right?
Yeah, order of n, because we'll have two pointers, and at max we'll be visiting each element only once.
Okay.
And the space complexity will also come down because we are not creating any auxiliary arrays in this
Okay.
case.
Okay. Yeah, I think this should work. So like which language do you prefer coding in?
I generally like code in Java.
Okay. So let's try to write like as error-free code as we can, which is handling like some
Okay,
of the corner cases that you can think of in Java.
okay,
So just
okay.
assume that you
So
have
can you write the signature for me, and I'll basically continue in Java after that. Can you
okay,
just write the signature?
sure. So just say that you get like you want to return an integer function, which is
Hmm.
basically get collected water, okay? And say it takes an integer array,
Okay,
and what you want is you just want to return like the water that is collected inside it. It's that simple a
okay, sure.
definition.
Okay, so so okay. So I just have to write the code for the function itself,
Yeah,
right?
like I don't worry about writing the main and all that. Like I just want a like running function. That's it.
Okay, sure. So this keeps capitalizing it. I don't know why.
Don't worry about that. I understand. Yeah.
Okay. Mm, So let's start. So initialize two pointers and is equal to 0 minus 1. And so initialize the left max with the 0th value,
Okay.
right max with the and then I have the water which is 0. Okay. Then this keeps auto capitalizing it.
Don't worry. I
Um,
don't worry
yeah.
about that.
Okay.
I'm not going to run your code
Okay.
right now, so
So
don't worry.
okay, no, that's fine. So in the end, we'll return the water, and in here we just need to keep doing this while start is less than equal to and okay. So now so now I am inside. So now I will check which value is higher. So if
Okay.
left max is higher, so if my left max is higher, yeah, okay. So what will I do? I will update this. Okay, so I'm thinking, should I update before or after this? Okay, I will think. Okay, so this much is for sure that water will be basically left max minus heights of start and start plus plus mm, and in the other case water will be right max minus heights of end and minus minus. So okay. So there's one thing which I'm confused about, like should I update the values before calculating the water or after calculating the water?
Okay.
Okay, so only part is left. I think I don't calculate. Okay. Hmm, I think I think I need to update before itself, because if I don't update before,
Yeah.
yeah, I think I need to update before calculating this, because let's say I am on a building of height 5 and my left max is currently 4, which has been calculated up to the previous step only, not to the current step. Then this value will become negative. The water that I'm calculating for 4 minus 5, it will become minus 1. So that updation needs to happen before I calculate the water. So heights of start. In similar way, right max is equal to max dot max, right max comma heights of and okay. So let me just like dry run it for
Yeah.
a
Yeah. Yeah.
couple of minutes.
Yeah.
Okay, so
Oh, wait, let me just copy the diagram from above to below so that.
okay,
Yeah. Go ahead.
okay. So our array was 5, 2, 5, 1, and water is here 3 and 1, 4. Okay. So 5. Okay. 5, 2, 4, 5, 1. Maximum of 1, comma 5, which will be 1. Okay. Okay. Yeah, I think this is fine, but okay, I'm seeing some problems that it will start calculating for the last elements also. So,
Yeah.
okay. So I can do one thing since we have already established that at least 3 buildings are needed
Yeah.
for it to store water.
Yeah.
So we can write basically edge case here that if the length is not at least 3,
Okay.
uh, then simply return 0.
Okay. Wait.
Okay.
Before we go into that, so
Okay.
so see, you are checking your left max and right max inside your while loop, right?
Yes. Yes.
Uh, can we add like some other check instead of that? Like, can we? So see, how are you deciding that if you are at these two corners, where will you move?
Mhm.
For that,
So,
yeah,
so basically, see, these 2 pointers like start and end are denoting 2 locations in the array, right?
yeah.
So let's say that your left max is smaller than right max. Then we
Okay.
can take a decision for the building
No,
on the
okay.
start pointer.
I agree with you. Wait, let's slightly modify it. Why are you
Okay.
considering the left max and right max? Instead of
So,
considering the left max and right max, why are you not considering the heights of those nodes itself?
okay. I mean, we can do that way also, but by using the heights, how will you do? So,
So like based on the two heights,
I
can we make a decision?
mhm.
Like where do we want to move? Should we shift here? Should we shift there?
um, no, I think based on the heights, we won't be able to decide because the heights don't matter actually. Like the deciding factor is uh, for which side we are able to take a decision. That is
Okay.
our deciding factor, right? So
Okay.
I can't decide based on the heights. I think I can only decide based on the maximum that I have for these 2 pointers,
Okay.
which are start and end. So
Okay.
if left max is smaller, so
Yeah.
then we can for sure we can certainly decide for the start pointer. If my
Okay.
right max is smaller, then I can certainly decide for the end pointer. But by
Okay.
using the values, I think we won't be able to take that decision.
Okay. Go ahead with this.
Okay.
Let's see how we are able to handle
Okay.
the edge cases.
So I'll just put it here that we need at least 3 buildings. Then this scenario will not come that it will start deciding for the last most points.
Okay.
And I think, yeah, this should be it. Uh, okay. So we can
Let's
actually put
try.
one more condition if we are just considering the, okay. So it should be non-null and have at least 3 elements. Then only we'll process it. I think this should work.
Okay. Okay. Um, let's go through a example one last time.
Okay. Okay.
Like let's follow the same
So
example. 5 to 4 5 1.
okay. Then initially start is 0,
Okay.
end is 4.
Okay.
Left max is 5, which is the 0th element. Uh, which is the 0th element, correct? And the right max, which will be 1, which is the last element.
Okay.
Now at this point, my right max is smaller. So we go inside the else block
Okay.
and then we update right max. Right max will become maximum of right max, comma heights of end, which is again 1. So right max will become 1
Okay.
and water, initially water is also 0 here. Okay. And then water will become right max minus heights of end. Right max is 1 and heights of end, which is 4, is also 1. So water will be 0.
Okay.
Cool. Now our start is 0
Okay.
and has been decremented, which will become 3.
Okay.
Left max is still 5. Right max is 1
Okay.
and water is still 0. Now my right max is still smaller. Okay. So
Okay.
then I again update the right max. It will become max dot max. It will okay. Sorry, the end is now 3. So the value at 3 was, let's copy this here. Okay.
Yeah.
So right max of 0, 1, 2, 3, 5. So right max will become 5,
Okay.
and water will become right max minus heights of end. So right max is 5 and heights of end is 0. So this will become again 0.
Okay.
Now start is 0. End has been decremented. It becomes 2.
Okay.
Left max is still 5. Right max becomes 5. Water is still 0.
Okay.
Now for 0 comma 2, right?
Yeah.
Now they are both equal, left max and right max.
Okay.
So it will again go inside the else block.
Okay.
Okay, so right max will again be updated. It will be maximum of 4 comma 5, so it will remain 5. And water will be
5.
right max
Okay.
minus my current height. With right max is 5 and current height is 4. So
Yeah.
water will become 4, and
Okay.
then it will be end will be decremented. So
Okay. What?
now start is okay.
Okay.
Yeah.
Yeah. Go ahead. Go ahead. You're right. Yeah.
Okay. Okay. So start will remain at 0.
Yeah.
End has now become 1.
Yeah.
Left max is still 5. Right max is still 5.
Okay.
Water has become 1.
Okay.
So now they are still equal. So we will again go inside the else block only.
Okay. And
Right.
update right max.
We
Okay.
again update the right max, which will be maximum of 5 comma end of 1, which is 2. So maximum of 5 comma 2 will still be 5 only.
Okay.
And water will be right max minus my current height, which is 2. So 5 minus 2, it will be 3 plus 1. So
Okay.
this is plus is equal to
Yeah. Yeah.
right. So initially it was 1. So 1 plus 3, it becomes 4,
Yeah.
and end will be decremented. So now
Okay.
start is 0, end is 0, left max is still 5, right max is still 5, water has become 4.
Okay.
So now these two are still equal, it will again go. So looks like our solution is never going into the
Yeah.
if block, but okay, so let's let it be. Then we again take maximum of 5 comma 5, it will be 5. Water will be right max minus my current height, so which is 5.
Yeah.
5 minus 5, so it will still remain 4.
Okay.
Then start becomes 0, end becomes minus 1. Left max will remain 5, right max will remain 5, and water has become 4. Now it will not work, because we have a end condition here that start is less than equal to end.
Okay.
So now 0 has become greater than minus 1. So at this point it will just return 4.
Okay. Yeah, I think this should be fine. So
Okay.
yeah, that's it. That's it for the interview. So congrats,
Okay.
you were able
So
to solve the
okay.
question I gave you. But
And do you did I miss any edge cases in my code?
no, nothing. Like it's good that you clarified the doubts in the beginning of the interview itself. So yeah.
Okay. Okay, man.
So
Let's.
yeah, thanks everyone for staying with us on the video. Keep looking out for the next video that we have. Probably the next time the tables will turn and the other Varun will interview the first Varun. So let's see how that
Yeah.
goes.
Yeah.
Cool.
Okay. Thanks, guys. And
Thanks everyone. Bye bye.
For new programming updates and videos, subscribe to Coding Ninjas channel.